Thank you. I'm going to give you a little overview of a system I've been working on for the last year or so. But in order to clarify something right up front, I want to understand it's not just me. There's several other people involved in the project, and I want to make that clear up front because people seem to attach everything to me sometimes, maybe because I'm the fool who gets up and talks about it, but that's okay. So let's start with a show of hands. How many people have downloaded something in order to upload it to another device? All right. How many people have downloaded something in order to share it with somebody by like mailing it to yourself or something like that? All right, that's good. How many people have downloaded, well, never mind, you get the idea. How many people here have bought digital media on, say, Google Play or iTunes or something like that? You're all wrong. None of you have. You've only rented it. If you lose the account, it's gone. So the point is, this stuff's kind of nutty, right? I mean, the picture's wrong here. Why is it that our data is so difficult to manage in the modern world? It seems like, in fact, we've gone backwards a bit. So a little bit of, let's say, personal history. There were computers before time sharing, but fortunately I didn't have to do them all that much. In the early time sharing days, which we'll call the 1970s, you logged onto a computer, all your people you worked with, your friends, maybe were on the same computer, and you could share stuff. You could say, here's the file name of the thing I'm working on, or something like that, and it was all very sort of community-like and kind of cool. Then in the 80s and 90s, the same kind of idea was applied across networks. So you could have distributed file systems, and you'd log on maybe in separate places, or separate offices, or even separate countries, who knows, across the internet, or with the ARPANET at the time. And it was the same kind of feeling, like you'd share stuff. Here's my thing I'm working on, you can have it. File systems like AFS and things like that. And that was pretty cool. And then the web came and sort of democratized it all, so that all your friends who weren't so computer savvy could suddenly access the net. But things started to go a little funny. And now in let's call it the 2010s, it's all in the cloud, and everything's out there and shareable, except you can't actually get it anymore. It's all hidden behind weird systems and strange things. And so, although there's no question that in many ways the modern world is much more interesting from an information standpoint than it was in the 70s, in particular, there's so many more people involved, and it's so much more fun, and there's way more cat videos. You've kind of lost your way a bit because you no longer have as much control over the data as you used to. Your data, your personal data. It's sort of owned by somebody else. Twitter has your Twitter feed. You don't. It's only available to you as long as you have your account and they don't get mad at you. And just last week, I helped somebody fail to get their account back from a service provider I won't mention that I work for. To have the world be so broken and so democratic and large is wrong. It shouldn't be a requirement that your data is that removed from you in terms of service, while we're removing it from you in terms of the good things about removing it, like maintaining it for you in the cloud and stuff like that. So the world's gone a little bit funny, and I don't like it. And I've been thinking about it for a long time and roped some people in to help me think about it some more. And we created a system called Upspin, which is very, very, very young. So this is actually the first talk I've ever given about it. So don't expect a lot, but I want to explain what it is and why it's the way that it is. Okay, Upspin is a global namespace. It's literally designed to be a global space that we all can live in and put all of our things in a sense that we can name them with this space. It's not really a file system, and that's because global names are much, much easier than global files. The reason for that is that files can exist on someone else's terrain. I can still give a name for it that I can understand. They don't have to update their file stuff. So the naming protocols that we have allow you to sort of talk to anything that's already out there. We're not required to speak only to the things that we create and own ourselves. And that's very important to managing all the data. You want to be able to name the things that are in your Facebook feed or on iTunes or whatever, not just the things that you create yourself. It's all glued together with secure federated protocols, which I'll talk a little bit about, but not too much. And so think of it as being federated in the sense that email is, that everybody can individually have their own services and they all connect into this nice, happy place, much in the way that email is kind of a global namespace, right? We all know if you give me your email address, chances are I can send you mail. Upspin is kind of like that for other data. We have a very nice sharing model, very simple. I won't explain in much detail, but I'll give you a flavor of it. So that I can share things individually. I don't have to make a file globally readable in order to share it with one person, which is a situation we often have today. Most importantly, perhaps, it's a layer above what's already there. We're not trying to replace anything. We're trying to connect what's already out there, be that social web services, file systems that exist already, your Tinder feed, who knows? Does you have a feed? I don't know. And another detail of this, which is actually pretty important to the design, although it won't be very obvious from what I talk about today, is it's not really meant for corporations. We're not trying to solve corporate problems. They're working on their own problems, that's fine. This is something for personal use. Personal privacy, personal security, personal data, not a company. Maybe your family, maybe a group of friends, but we're not trying to save all of a company's data. And I need to explain a few things that Upspin really is not. It is not a file system, although it can act like one, and because of the way the names work, it sometimes feels like one. But again, it's a namespace, not a file space. It's not AWS or GCS. It's not a new cloud platform. It's not something like that. It's not Dropbox, although Dropbox is pretty cool. In fact, I'm presenting off Dropbox now. Dropbox has this problem, I think, which is everything gets copied everywhere. And since I'm a person, like I imagine some of you, who has a lot of machines, it's kind of crazy the way Dropbox copies everything everywhere. Convenient, but not practical when you're talking, say, petabytes. You can't have all of that copied everywhere. And Upspin would work at petabyte scale. It should. Not everybody has petabytes, but lots of people have terabytes. And I don't want terabytes copied everywhere either. It's probably most like Keybase, although it differs profoundly in the way the sharing works and in the intended audience. And as you'll see, also in the kind of data it can handle, but we'll get to that. And so, as I said before, the goal of Upspin is to take all these things that are already out there, but unify them into a single way to access them, share them, secure them, name them. So let's talk about these names. You all know the Unix file system space, I guess. It's equivalent to a lot of other systems you've seen out there. Upspin is a little bit like that, but there's no root at the base of the entire space. It's not a tree, it's a forest. Every user has what we call a private root, user root, and then the names of the things that are owned by that user lives underneath its own private root, which is named beginning with the username of the user. So an example makes it really easy to see. I might have an Upspin name, r@golang.org/stuff. r@golang.org is my username, and then the rest is a Unix-like file path that gets me to the Upspin object. Now, we're using email addresses syntactically, but semantically it's actually irrelevant that it's email address. Once you've registered with the system, the fact that it's an email address is irrelevant. It's just a piece of syntax. And there's a fair bit of discussion about maybe changing the way the usernames work. It's not important to the structure of the system at all. It just gives us an easy way to verify who you say you are when you grab a name and want to sign up. And then a terminology which will be important in a second, which is this user, which in this example is r@golang.org. That's called the owner of the tree, the Upspin tree beginning at that root. Okay? Then there's a sharing protocol that works above this. And unlike a lot of systems, the sharing is actually done by plain text files within the Upspin tree itself. So it's not metadata for the sharing. It's actually just a plain text file, which makes it both easy to work with, but also it's always really clear what's going on with sharing. Who can see this thing? The way it's done is there's a thing called an access file, which you can drop in any directory that defines who has the rights to do whatever in that directory. Read, write, open, close, whatever. Not close. Read, write, delete, list, things like that. There's 5 of them. And the text files look like this syntactically. There's one of the rights, like read or write or list, and then just a comma or even space separated list of Upspin names. And this last one on this example is the word friends. Friends here is a group, and it's a group of group of people defined by the owner of the tree in which this access file lives. And a group file might look like this. It's just a list of other Upspin users, including groups if you want. So a group file might say these 2 people are in a group and we're going to work together. And so I can just use that simple name to provide access to that specific set of people securely. And then just in case the security people worried about this, how open this looks, only the owner can modify access in group files. So I can't give you access to the access files. Only I can do that. And that's a simple rule. But that's just protocol. That's not really security yet. The real security is that when Upspin stores data, which it can do, it can name data it doesn't store, but when it stores data, it's end-to-end encrypted by default. So no one ever sees the clear text except the person whose data it is, or the person who's explicitly being allowed access to it to share it. Okay? And it's encrypted at rest, which means that the storage servers in the cloud, which might be holding this data, never see the clear text. It's always encrypted. They can't read it. More importantly, the storage servers never even see your private keys. Public keys, sure, but not your private keys. So we have some belief that this is if you want it to be, you can use it as a genuinely private store where nobody can snoop around in your stuff. And I'll show you a couple of examples later of how that works. And the access control stuff I mentioned on the previous slide cooperates with the encryption in a way that works really nicely. If you have two people allowed to talk to a file or read a file, then the security protocols allow only those two users' keys to work on that file. And there's a technology for doing that, which I won't describe in detail, but security experts probably know what I'm talking about. I am not a security expert. So how is this put together? I'm not going to really show you much working stuff, although it does work, and I'll give examples later of how it does work. But I want to show you a little bit about how it's put together, because it's a very Go-centric model. Of course, all the code is in Go. There's 3 servers. I'm going to show you the complete interface to the system that matters. There's a couple of other administrative details that you never see. There's one key server in the world, and it's called key.upspin.io, and all the systems know about it. And that is where user data is stored. And that it's one server or one group of servers cooperating, because the key to making all this work, so to speak, is that all the users live in the same namespace for users. If it splits into 2 separate groups, the whole system breaks down because we won't be able to share between the communities. So we want one community, they're all sharing a single key server. And that can be replicated and protected in other ways, but conceptually it's just one server. And then there's a storage server and a directory server. There can be many of those, and we expect there will be many of those. They might be at the scale of every user having their own storage and directory servers, or it might be a family or a group, or perhaps a company if a company wants to use it. And so there are lots of them. So think of, like, by my old analogy with Gmail, or email, pardon me, there may be email servers all over the place, but they can still talk to one another because they all understand the namespace at the top. Okay, so here's the complete interface to the key server. There's 2 methods. And of course, these are implemented across the wire as well as locally. It's the usual story. You can either look up a user, and you look up by username, like art@golang.org, and you get back a thing called the user structure, which contains the username, the public key of the user. I'm going to get public and private wrong once in this talk, I know. Public key of the user, and also what the network address of the directory and store servers for that user's information are, because that's important. Actually, you only really need the directory server. And then you can put back a user if you want to update the user record for that person. Of course, that's very strongly protected. Sort of typically, the only person who can do that is the owner, although there's situations in which you're administering a domain, you might be able to do it for multiple people. But conceptually, you can put back your own thing to change your keys, to migrate your service, whatever you want to do. That's trivial, right? Here's the much more difficult storage server, which has 2 methods. You can either get based on a reference, or you can put data back and get what the reference is. That's the complete interface to storage. Typically, but by no means exclusively, it's typically content addressing using hashes. And so when you do the put, you get back the hash. Then you look up the hash, you get back the data. Very, very simple. Okay, this one is much more complicated. It has 6 methods. This is a directory server. And you can see it's got simple stuff: lookup, put, glob, which is global, like matching star patterns. Delete, and then which access has a security thing. It lets you find out which access file is in force for this particular path. And then watch is a way to watch events happening if you want a tree and see what's updating on it. So it's pretty simple. There's only 6 methods. Between the 3 servers, there's literally 10 methods, which is pretty small. It's 4 fewer than Plan 9, so that's good. It's getting smaller. Notice there's no get. You don't ask the directory server to get your data. You do a lookup of the name. He gives you back the list of references for the name, and then you go to the storage server to get them. And that's just a design decision, because it might be cheaper to not do it, to have the directory server do the second order lookup for you. Also, the directory server and the store server will often be different machines, so there's no reason to go through 2 hops when you can do it in one. And the sort of reference primary implementation we have now for the for the directory server is a Merkle tree. That is to say, it's hashing the directory records and storing them in a storage server of its own. So it's using the store server technology to store the data for the directory server, but they're actually different machines. Okay, and then there's a client library. This is entirely a library now. The other things were services, which might be local, might be across the network, but the client is a totally local interface, and it gives you more traditional API to talk to these things, like file-like stuff, read and write and that kind of thing. Absolutely trivial, and a couple of other hooks for getting at Upspin-specific things. And using the client library, there's some special tools that have been written to play with Upspin things. The most important one is called Upspin FS, which is, of course, a file system that you can mount on Unix systems using Fuse that gives you a mount point into the entire Upspin namespace, globally, not just your own stuff. And so when you run Upspin FS, you give it a mount point, like I like /u, it's short. And then you can do things like cat/u/r@golang.org, some stuff, and see the contents of that file. But I can also cat/u/any other user in Upspin /something, and if I have permission, I can see that data as well. So that brings it all into the Unix space, which is really, of course, what we want most of the time, although there are other uses like phones, which for some reason don't have file systems. Don't ask me, I didn't invent them. Let me give a few examples to show you what I think this system is capable of. I should probably give you a demo, but the demos aren't as compelling as me just telling you. So they do work, though. At least some of them do. Let's think of a media library. My Lightroom, what's the word for it? Catalog. My Lightroom catalog is stored in Upspin now. It's living in a Google Cloud instance, stored with store servers running there. There's a directory server there, and so on. And that means nothing big in terms of the way we used to think about computing. What it means for me personally, though, is I have exactly the same Lightroom catalog visible on all the computers I own. I don't need to copy it around, sync it up. I don't have to do that rsync nonsense when I move between machines and so on. It's a single library, but also it's in the network, so it's available anywhere, but it's also encrypted, so nobody else can see anything in there, and only I can see it. Unless I wake up tomorrow and I decide, this raw file on this day with this cool picture I want to share with somebody. I don't have to download and upload it. I can just drop an access file granting you permission and then mail you the name or send you the name of that object, and then you can use Upspin to go get it. I don't have to download it and mail it to you or some such, shall we call it, horseshit, right? It's just accessible. Another example, same thing with my iTunes library, is also in Upspin. Now it's a little different because it's a combination of stuff I've bought from Apple and stuff that I've ripped myself from CDs, and I don't want you to be able to read the stuff I've paid for. It's not right, you should pay for it yourself, but I do want Renee, my wife, to be able to do it, and so my iTunes library is readable by her and me both. So she can see our shared catalog that way using Upspin security. It's all still protected, and it all just works. In fact, as far as I can tell, it works great. I can't tell the difference between doing it this way and doing it locally. It's really good. As another example, so far all I've talked about feels like static files. That's never the interesting thing in these systems. Imagine you have something like a security camera, or your parent, you got a newborn, you want a nursery camera. You can put the camera into Upspin by running a little directory storage server nearby or on the camera, depending on how much control you have. And then you've got access to the data, whether it's a video stream or a series of static frames, whatever it is, but it's encrypted. It's accessible only by the people in your family, which might be the name of an Upspin group you've created that has you, your wife, and your other kids or whatever. And it's now, I can't protect the camera itself. Other people can come in and do whatever they do with these crappy devices. But at least as far as the data that you're accessing it, it's secure, it's protected, and it's a streaming service. But it's in the same namespace. And if for some reason I want, I don't know, grandma to be able to see the nursery camera, I just change the access file, put grandma in there, and now from grandma's machine she can see the pictures. But again, nobody else can. It's protected. Okay? So that's a different example. I want you to understand this is not about naming files and securing files. It's about accessing information securely with nice, simple sharing. Okay? The example, this is the one I want. And I think it's not quite there yet for real use, but I want $home to be here. I don't want a disk on my computer to carry around with me. And let's face it, that's why you carry a laptop around. It's because it's got a disk in it, and that's got your stuff in it. So what? You know, why are you carrying your data around with you? It's crazy. Well, there are reasons. The modern world makes it necessary, but I think it shouldn't make it necessary, and we can fix it. So I want $home to be an Upspin, and there are intimations that that's starting to be usable. Dave Prezzato, who's one of the guys who works on this, has one Git client. It's in his Upspin, and so when he has two places he goes back and forth between, and when he logs on two places from two different computers, it's the same Git client, same state. Hangs up in the, leaves work, goes home, turns on his machine. Git is in exactly the same state as when he left it at work. He doesn't have to sync between them and all these other confusing things that he and I are too old to understand with Git. It just works. That's the state that I really want to get into. And I think we're months away from having that be my default state too. We'll see if that pulls off. There's also Chris Foster, right? He's actually here, has created a little service, which he'll have to tell you more about it maybe in a later Gopherfest. But he's building on top of Upspin a more sort of fine-grained thing for people who don't want to deal with running more complicated stuff, so that you can, for instance, his example here, share your treasure map with your pirates or tax returns with your accountant or something like that at a very fine-grained level. And the Upspin API makes that very simple to do, even in a way that existing services can interact with. So what's the status? It's very, very early days. We've been working hard mostly on the protocols and the reference implementation, which is pretty much done. It's not that much code, but I think every line has been rewritten about 30 times. But it's settled down quite a bit now. The implementation works with GCP and AWS, thanks to Andrew, who just left. Came up over the weekend, I think. Unix works fine. Basically, any Unix will do. Windows, everything works except we don't have a file system plugin like Fuse yet. But I hope that might come, maybe through the open source world, because this is all open source, and we're really encouraging people who think that it's reasonable to have access to your own data the way you want it, would be willing to help us make this all work. Of course, every line of it is in Go. The actual vendor dependencies are really small too. It's pretty much self-contained with a few small exceptions. The web domain is, of course, upspin.io, and everything you need to know about it to get started is almost there. There's definitely some documentation improvement, but there's enough there to get started. And we'd really like some help for things like UpspinFS for Windows, but lots of other things too. Now, the most important thing, of course, is there's a Mascot. You can't have a project without a Mascot. And Renee designed another Mascot for us, and this is Augie, and he's got an attitude. But he's basically skeptical about all those people trying to steal his data. That's what that's about. And that's it. Very high level, very simple. Thank you.
That was actually perfect, because online people were asking what is on your shirt on the feed. And I knew it was by Renee, but great to know that it's the new Mascot that we can now get really excited about. There are a couple questions. Sorry if I don't get to them all. I'll start with this one because I think it's relevant. What is the actual federated wire protocol it uses? Something custom or something standardized?
I showed it to you. It's this.
Oh, did you show after?
That's it. That's the, sorry.
He showed it to you.
That protocol. That's the complete protocol.
Sam?
I mean, there's a couple of data types missing here, but those are the 10 methods that it's all built on.
Awesome. Do you think media service, this is from Harishran, do you think that the media service use case would encourage piracy of content as everything is encrypted now? Doesn't sound
No, I've never encouraged people to break the law. That's up to them. No, I'm serious.
Don't break the law.
Don't break the law. But I believe that on the flip side, I don't want the law breaking my data either. So that's the way I think about it.
Oh, yeah. All right, they're giving some really good questions, but I'm not going to get to all of them, and I will give the opportunity for a couple of you as well. Regardless, let's go with how is Go's concurrency features work in Upspin?
Well, there's the scaling, which is built right into the libraries, of course, which works really well. And probably the most explicitly, unusually Go-like thing is this watch API in the directory server includes a channel, actually 2 channels, which make it easy to write. It's tricky to implement. It's actually the hardest method of all these to implement. But it's pulling channels out of concurrency and works pretty well. And then making that work across the wire was a bit of fun, but we got it working. Mostly, Andrew did most of that work. So I think the real answer is the way it scales really nicely.
Okay. And Bryce Cubed, I'll get to the second part of your question because the first part is hard to read. Could you store sensitive information like tax records in Upspin?
Yes, absolutely. That's kind of what it's for.
So you can host your own storage server.
You can store very sensitive stuff and share it with one person, like your tax account. That's a perfect example. And in fact, the jungle that I showed you, this guy.
Oh, that's a good question too.
That's one of his examples.
Any thought of applying this to private chat, like in Keybase, at all?
I haven't thought about it specifically, but absolutely, it would work for that.
Yeah. So what transport does it use? Is there plans like HTTP?
We use gRPC for transport and had a lot of performance problems, especially on high latency networks. So we stubbed that out for now and are using a custom HTTP thing we wrote ourselves, which it's protocol buffers in HTTP. It's about 100 lines of code. It's absolutely trivial. I suspect one day we'll throw that out and put gRPC back in once gRPC gets the performance back, which is work that's underway. But at the moment, it's a custom but extremely simple protocol.
And what are your thoughts on IPFS?
IPFS is another one of those global file systems, but it doesn't satisfy the combination of things that Upspin. There's a IPFS, Keybase, Dropbox, AFS. There's like 100 of these things, and they're all a little bit different. I think there are 2 fundamental things that make Upspin, well, maybe 3 that make it different. One is it's targeted at people rather than companies or organizations. Another one, which I think is really interesting and hasn't been explored yet by us, but we're very aware of it, is the directory server and the store server are not the same machine necessarily. They can be, but they don't have to be, which makes things possible. Something I'm going to do very soon is twin my directory server and storage servers. So there's a version on AWS and a version on GCP. So if one cloud provider goes down, I've still got access to all my data. That's actually very straightforward with the stuff we have. And then the sharing model is actually really unusual and I think really pretty. It's very, very simple to not only set up sharing, but also to look at a file and understand what rights are granted to whom, because it's just a plain text file in a very simple format with very simple rules. And that, the idea of ACLs being this sort of metadata on the side that most systems have, I find baffling. Now, Keybase has public and private as 2 subsets. Those are very, very easy to understand, but I want one in the middle. I want my family, and that's a specific difference, right? So I can talk about any other 2 systems, but the key point here is to understand we're not trying to displace any of those. Our goal is to go on top of them all like an umbrella that glues them all together. So I can have my Dropbox data, my Keybase data, my IPFS data, my local file systems, my iTunes data, my Lightroom data, all available in one thing where the same rules of access, privacy, and shareability apply. How's that?
I have 3 more questions that I'm going to take. I've already picked out who they are based on them raising their hands first, so you can put your hands down. Here's one.
Given going back to the piracy thing, can Keyspin reverse look up who is sharing the files? Is there any fingerprint of me sharing the data to you and someone else can see that?
No, because this is part of the beauty of having the access files be plain text in the tree. They're protected by the same rules that they define themselves. So if an outsider tries to read your access file, it's denied. They can't see it. So they can't reverse engineer it unless they're specifically granted permission to come in and see it. It's part of the design. Yeah. It's clear. It's not opaque metadata on the side. I mean, they might be able to do some traffic also of the network. I don't know, but in principle, no. Yes.
How does Upspin integrate with other people who hold data such as like a Twitter feed? Is it just it defers to that system for the data, or does it actually ingest
Yes.
that?
What would happen, I would love to see, I mean, we haven't done this, but I'd love to see it. What would happen was Twitter would take those trivial methods I showed you and provide that API to the data. They'd implement the data service, and then I'd have Upspin names for all the elements of the Twitter feeds. That's the goal. Right? Now, are they going to do it? I don't know, but I'd love them to.
Yeah, I just wanted to know who owns the key server?
Who owns the key server? Well, it
Yeah,
runs
like
in
who's
Google
paying for
Cloud. It's open source, and at the moment, it's the team that runs it. I guess you could say we own it. It's not a comfortable situation, and there's been some discussion on the issue tracker about what exactly that kind of thing means and how secure and safe it is and all that. We actually don't want to run a key server. We're just doing it because there isn't one available for us that suits our needs right now. As you can see, with such a trivial, 2 methods, get a user, put a user, just about any service could do. We just want to find one and let someone else take it over. And there's several candidates, they're just not quite ready yet. I wouldn't be surprised if next time we talk about the system, we're not running the key server anymore. It's some other party. All right?
Thank you so much, Rob.
Thank you.